Okay, so in this video, I'm going to be evaluating the definite integral at 0 and 1. So this is the lower bound, the upper bound. And the function is going to be 2x squared minus 3x dx. Again, this is the definite integral that I need to evaluate. So just as a disclaimer, I wanted to point out that I'm doing this problem, and many of the problems that I do right in front of the camera, and this is the first time I'm doing this problem, so it's going to be the real life experience. Okay, so let me first split this into two parts. This is going to be the definite integral. That was messy. The definite integral evaluated at 0 and 1 for 2x squared dx, and then minus the definite integral evaluated at 0 and 1 for 3x dx. So this is gonna become, so let me actually rewrite it one more time for both of these. So this one is gonna become 2 times the definite integral evaluated at 0, 1, x squared, the 2 is gone now, it's outside, dx, minus the 3 times the definite integral, 0 and 1, this is just x dx. Okay, so now that we have this, let me change my color just so it looks colorful in the thumbnail. So let me do this in, let's do blue this time, not green, let's do blue. So this is going to be equal to, I'll do this on this side, continuation, so this is continuation over there. So this is going to become 2 times, so let's find the antiderivative of x squared. So I'm going to do the same also with this later on. So antiderivative of just x. So this is going to be x to the reverse power rule, right? So x to the third power over 3. And this is going to be evaluated at 1 and 0. And we're going to take the difference of this evaluation. And then this is going to be, so this stuff minus, I don't know if I can fit it over here. Probably can't. Let me do this down here. So this is going to be this stuff minus 3 times, so what is the antiderivative of x? That's just going to be x squared over 2, right? X squared over 2. This is going to be evaluated at same thing, right? 1 and 0. So let's do this. Let's see, this is going to become 2 times 1 cubed over 3. So this minus, right? I'm kind of separating it because we have to do this difference, right? So this is going to be minus 0 cubed over 3, and I don't even need to include that because 0 cubed is 0 over 3, 0. So that's just this. All right, minus 3 times, let's include it here. Actually, I don't need to include it necessarily because we have a 0 again, but anyway, this is just going to become 1 cubed or squared over 2. And minus 0 squared over 2, which is just 0 over 2, which is 0. Okay, so this is what we have, and so this is what we have. So this is going to be equal to 2 times 1/3, 2 times 1/3, right, minus 3 times 1/2. Okay? And yeah, that's what we have. And let me scroll down a little bit because we're kind of running out of space. So let me scroll slightly down. So this is going to be equal to, 2/3 minus 3 by 2, or 3/2. So technically, this is what we have. What we can do is we can create a common denominator. So this is going to be 3 times 2. And let me do that in a different color. So I'll just multiply, go to red. I'll multiply this by 2 and this by 2, and I'll multiply this by 3 and this by 3. So this is going to be equal to, and I have to scroll a little bit down again, is going to be equal to 4 by 6 minus 9 by 6. And this is equal to negative 5 by 6. And that is the evaluation of the definite integral problem we had in the beginning. So again, just to recap, right, what we did, if I scroll a little bit up, right, what we did was we split this up Then we further simplified using our integration rules. Again, review them if you don't remember. Then we found the antiderivatives of the functions, right? And then what we did was we evaluated them at the two bounds of integration, and we took the difference. And here it's just 1 because minus 0 is just 0 for both of these. And then this is what we got once we evaluated, once we simplified. And we got 2/3 minus 3/2. We multiplied by 2 for the 2/3 on the numerator and denominator. We multiplied by 3 on the numerator and denominator for the 3/2 just to get that common denominator. And then we subtracted, we took the difference, and we got negative 5/6. And this should make sense because a definite integral problem should yield a exact result. It shouldn't have any variables involved. So that's exactly what we got. So that shows that we're on the right track. So I hope you found this video helpful.